So today's topic is related to hold on. Today's topic is related to sectional view. Okay, it's one of the views that we have. One is the sectional view, full sectional view. We have half sectional view. We also have auxiliary view, oblique view, and so on. But today we're going to talk about sectional view. So imagine yourself having a cake. Okay, imagine yourself having a cake, and you cut the cake into a section. Okay, if you see inside the cake, you have that is what you call a sectional view. Okay, an example of a sectional view. It's one of the views to actually to help you visualize the interior of the feature or the internal features to help you to understand the components of a part. Okay, for example, if you are missing a hole, okay, there will be a hole inside, for example, so you need a sectional view. Section views are also used for hidden objects, okay, that are not shown in the interior or that are shown in the interior but not shown in the exterior. Okay, some of these details appears as a hidden line. All right. Therefore, the shapes are not very well described in orthographic projection. Thus, you must use a sectional view to explain this hidden line. For example, this drawing over here, you cannot see from the front view because it's hidden. You can see from the top view, but you do not know how deep depth is the hole. But using a sectional view, you can see the depth of the hole. So, section view shows an object that would do when you cut with a cutting plane or a saw to the object and the material in front of the cutting plane is discarded. Okay, yang kat depan ni, this front is discarded and the back will be uh, will have an interior feature, a line diagonally, okay, a line with a diagonal line of stripes of diagonal line. So the viewing direction is the one that is cut in front of you from the front plane. So an example of a section line is a cross hatching, which is used to show where the cutting plane passed through a solid material. Okay, this is called a cross hatching, the line that is used to cut. So a normal view on the bottom left side, you can see there is a hidden line. Okay, a hidden line. Whereas on the right bottom side view, you can see that when it is cut with a cutting cross hatch, you can see that the section view has a diagonal line. So that are the two differences of a between a normal view and a section view. Right. So these are the types of sectional view that you can find. First of all, the full sectional view, half sectional view, offset section view. There's a revolve view. Revolve view mostly occurs in objects that are rotating at the central, okay, at the center axis. A remove section view, broken out section view. So these are the 6 that we'll be talking today. Next time we'll be talking about the auxiliary view. For a full sectional view, the cutting plane that cuts across the object is entirely, okay, all of it. The hidden line becomes visible. If you look at the bottom right hand side of the picture, the hidden line becomes visible. Okay. Even the circle becomes visible. The center line appears. but there is no hidden line anymore. A full sectional view, okay, of a stock view, okay, makes a full section of the front view. So if you make a full section plane of a top view, you can, if you cut the plane on the top view, you can see a full section view on the front. All right. So look at the picture on C. You can see that the full sectional view, when it's cut on the top with a front using a top view, the front view becomes a full sectional view. So basically, you can see the difference between the first circle and the middle circle, the middle diameter of the circle, and the first cylindrical diameter. There are two differences. Kalau kalau tak ada hidden line, sorry, kalau ada hidden line, kita boleh nampak the differences, but guna sectional view, you can see a relatively much difference, okay, between the first cylinder on the top and the cylinder inside. Another example of full sectional view is that the visible line is not omitted. Okay, the visible line is not omitted. Look at the top and the bottom picture. You can see the differences between the uh, figure. Okay, the top figure is not correct because the visible line has been emitted, whereas the bottom one, the visible line still appear. So basically, full sectional view, you must have the visible line everywhere. Okay, mesti ada. Even for something that is not even there, right? Okay, sorry about that. The next one, we're going to talk about half sectional view. So the half sectional view mostly cut half. That's the difference only. Okay, they intersect at the center line. The difference between full sectional view, you cut with a plane. Okay, half sectional view, you cut with a half plane. That's all. Most of the half sectional view mainly use a symmetrical object. Okay, like a circle or an object with the same face on the side and the front. Different different what do you call that, objects cannot be used using a full half sectional view. For example, um, you can use a car. Okay, a car as a half sectional view because both right and left are equivalent, but you cannot cut the car from the front and the back because those are different, right? Those are different. An offset sectional view, and the third one, are used to show interior feature that do not lie between the straight line. So an offset view is not more a straight plane. Plane ni dia macam satu kertas yang dipotong, kertas yang memotong objek itu. So kertas itu, bila kita gunakan offset section, dia bahagikan kertas itu, melipatkan kertas itu kepada 3 bahagian. Right, 3 parts for example on an object. You can draw it to 4 parts, even 2 parts. It's called an offset. The main is that it does not lie on a straight plane or a straight line anymore. Now, if you look at the figure on the left side compared to the figure on the right side, what are the difference? The difference is that the line of the offset is not shown. Okay, it's not appear, does not appear. So you should not appear make the line as as an object line. Make sure the offset line, offset sectional view line does not appear, does not appear on the sectional view. Do not draw any line on a sectional view. Okay, that is the most important thing. Okay, on this diagonal line tu, jangan lukis satu pun line on top of it. The fourth one is called a revolve section view. A revolve section view shows the shape of an object that when it cross section or a superimpose on a longitudinal view, okay, when it's straight horizontal view, sorry, vertical view, you can see that the cross section, but always remember that a revolve always has a center that rotates. Okay, a center of let's say center of an object, and it rotates. So it has to have a four section likely mostly to be the same. For example, in figure A, and in a cross section view in figure B, you can see that when you cut the figure, you can see in part C of the revolve section view of part A, and then part D, the revolve section view of part B. Okay. Most of the time we seldom use revolve sectional view because you can also use full sectional view to view that. Okay, revolve sectional view are mostly in small bit tad details, not that big. The fifth one is called a remove section view. Okay, a remove section view is when you make the section appear outside, okay, outside of the figure. For example, you look at section AA there, the cross section of AA, you can see that it is placed outside of the figure. For same goes to for CC, BB and CC section view. The remove section view, you can place the section outside, but the section line of section BB most you can mostly see it as a straight line rather than diagonal because of the way the picture is explained. But remember, always has a diagonal line as a section view. And also they are named section AA, section BB, section CC. Right? So those names are important to write a remove section view. And finally, the broken section view. So a broken section view is when you have, say, an example of a figure, okay, a detached figure, and you have both the hidden line and also the section line, as well as the object line, the the straight line. So must have those three. So these are all the six broken out section view. Sorry, all the six of the sectional view that you can find in a CAD design. All right. So any question? Any question on the sectional view?
No, sir.
No question. So far, okay. Eh?
Okay.
All right. So one more topic I'm going to add. Okay, is regarding about, since I don't have a screen. Sorry, I have a screen, but I don't have a whiteboard. But I'm going to use a book. Right, I'm going to use this book. So this is a book on auxiliary view. Okay, another view we can find is called an auxiliary view. An auxiliary view is mostly shows the true size and shape of surface that is not parallel to any six principal views. What does this mean? You want to find the sloping line, the true length of a sloping line of an object, to find the true size and shape of an inclined surface, to find the point view of an inclined surface, okay, to look at the object in a different plane that is not of the principal plane, so that the object can be viewed differently to, or to start successfully on the auxiliary view. So, say you have a pictorial view of this, okay, a pictorial view of this. You want to, if you have done orthographic view, okay, the top view mostly from a third angle view, right? From a third angle view, you can see the top view is as of this true size and shape of an inclined surface, but it does not show what the inclined uh, shape is. The front view, however, and the side view, the whole appear more elliptic rather than a circle. Kan? So what when this surface is not perpendicular to the line of the side, you need a true length. But you cannot have this true length. You don't know this true length because it is an ellipse. So auxiliary view allows you to look at directly in an inclined surface. For example, shown in this figure 9. Figure 9.3 here. This is the true size and the shape of an inclined surface. This is a partial view. So you need to take from this view of the top view 90-degree angle. You can find the length of the this one, this size here, right? This size, which does not shown in the either top or front view, because the top and front view looks highly different, right? That is called a partial view, auxiliary view. So the projection is at 90-degree angle from the view where the inclined surface appear as a line. Okay, it becomes a straight line. Here, when you draw in a look at the front view, it doesn't show the length of this face here, right? But the length is basically a h. However, it does not explain to you where the circle is. In figure 4 also, the auxiliary view shows only the true size and the shape of the inclined surface. Okay, only shows only the true size. This is known as the partial auxiliary view. However, the full auxiliary view, okay, in figure 9.5 shows the true size and shape of the inclined surface. Normally, a partial auxiliary view is used because the partial auxiliary view shows only what you need to provide the true geometry of the inclined surface. So in figure 5 here, kalau you can see, this is the full auxiliary view. A partial auxiliary view has only up to here. A full auxiliary view, the additional of this, as well as um, hidden lines, okay, as well as hidden lines compared to Partial does not have hidden line. That is one. That is also an auxiliary view. So another way to look at an auxiliary view is by replacing the um, figure, right, like this, an isometric view. This is a front third view. Okay, this is a third, sorry, this is a front view. This is a first angle view. The third angle view. Sorry, third angle view. So when you see a third angle, you can place the auxiliary view on the between the top and the side view, right? Just like this example of this one. So I'm going to pass you this pass you this notes for you to read. I'm going to add this in the slide. Sorry, I'm going to add this in the column to help you with your with your drawing. All right. So that's all for auxiliary view. Okay. So